You think space is cold, not just cold. You imagine it as the absence of temperature itself, a perfect emptiness, a cosmic freezer, a place where heat has nothing to cling to. You picture temperature as something that belongs to stuff, to air, to atoms, to bodies, and space in your mind is the opposite of that. No air, no particles, no motion, so no heat. That feels obvious. It feels like common sense, but that picture is wrong, because you've quietly assumed something, that heat requires matter, that temperature requires substance, that emptiness cannot carry warmth. You imagine space as a background, a passive stage, nothing happening, nothing moving, nothing real. But space is not nothing. And the most unsettling part is this: even where there is absolutely no matter, space still has a temperature. Not metaphorically, not poetically, physically, a measurable heat. And if that's true, then your idea of empty has already collapsed. You think space is cold. That's the first image your mind reaches for. A black emptiness where warmth cannot survive. A place so distant from life that temperature itself disappears. You imagine cold as the natural state of the universe, and you imagine heat as something temporary, something local, something trapped inside planets and stars. This feels obvious because on Earth, heat lives in air. It lives in molecules colliding. It lives in things you can touch. So when you hear the word vacuum, you picture the absence of all of that. No air, no atoms, no collisions, so you conclude no temperature. That conclusion is wrong, not because space is secretly full of gas, not because the universe is warmer than you thought, but because the mental picture itself is broken. You are treating temperature like a substance, as if heat is something that fills matter, and emptiness is simply what remains when matter is removed. But temperature was never that simple. Even the phrase space is cold hides an assumption. Cold compared to what? On Earth, cold is a relationship. It is energy leaving your skin. It is motion slowing down inside matter. But in space, there is almost nothing to slow down. The universe does not behave like your intuition, because intuition was built inside an atmosphere, inside a world where emptiness is impossible. You have never experienced true vacuum. You have only experienced less air, and that difference matters more than you think. When you imagine deep space, you imagine silence. But silence is not the absence of sound. It is the absence of a medium, and temperature is similar. You assume heat requires a medium, that without particles, warmth has nowhere to exist, but physics does not agree. Space is not a passive backdrop. It is not a blank canvas. Even in the emptiest regions between galaxies, there is a temperature, a real one, not a metaphor, not an approximation, a number you can measure, which should bother you, because it means emptiness is doing something. It means the universe cannot reach the perfect cold you picture. And it means the phrase "nothing is there" is already unstable. The moment you accept that space has heat, you are forced into a deeper question. If even nothingness carries temperature, then what exactly is nothing? You think temperature is a property of objects. You look at a cup of tea and say it is hot. You touch ice and say it is cold. So temperature feels like a label attached to matter, as if heat is something stored inside things, like water in a bottle. But this is wrong. Temperature is not a substance. It is not a material. It is not even a thing you can point to. Temperature is a statistical idea, a description of motion, not motion you can see, but motion hidden inside matter. Atoms never sit still. Even in a solid, even in something that looks frozen, the particles are trembling. Always, heat is not contained in an object. Heat is the restless energy of microscopic motion. Temperature is how we measure that restlessness. Hot means the particles are moving violently. Cold means the motion is quieter. So already, temperature is strange. It is not about the object itself. It is about the invisible swarm inside it. And here is where intuition collapses. Because you assume motion requires matter, you assume temperature requires atoms bouncing around. That seems reasonable. No atoms, no motion, no temperature. But physics does not define temperature as how warm matter feels. It defines temperature as energy distributed among available degrees of freedom. That's a colder, more abstract statement. And it matters because energy does not only live in atoms. Energy can live in radiation. Energy can live in fields. Energy can live in the fabric of space itself. The mistake is thinking temperature belongs only to solids, liquids, gases. That's just what you grew up with. On Earth, temperature is tied to air because air is everywhere. But temperature is deeper than air. Consider this. If you place a hot object in space, it cools down. Not because cold air steals its heat, there is no air. It cools down because it radiates energy away. It glows invisibly in infrared. Heat escapes as light. So temperature is already connected to emptiness through radiation, which should unsettle you, because now heat is not trapped in matter. Heat is something that can exist as pure electromagnetic energy. A photon does not need a molecule to carry it. Light moves through vacuum perfectly. So if heat can be radiation, then the absence of matter does not guarantee the absence of temperature. And this is the crack in the mental picture. You thought temperature was about touch, about substance, about particles, but temperature is about energy and motion does not require matter in the way you think. Once you see that, the question changes, not how can space have heat, but what forms of motion exist even in emptiness. You imagine a vacuum as blank, a perfect removal. Take away the air, take away the dust, take away every last atom. And what remains in your mind is pure nothing, stillness, zero activity. So when someone says space has a temperature, you instinctively resist. Because temperature feels like evidence of something being there. And nothing, by definition, should leave no evidence. But this is where physics becomes uncomfortable, because emptiness is not inert. A vacuum is not a dead stage. Even if you remove every particle, you have not removed reality. Space is still filled with fields. Electromagnetic fields, gravitational fields, quantum fields. These are not optional. They are not decorations added on top of space. They are what space is made of, at the deepest level we know. And fields do not sit quietly. Even in their lowest energy state, they fluctuate. This is one of the strangest facts in modern physics. The vacuum has activity, not because particles are hiding there like dust in a room, but because nothing is not allowed to be perfectly still. Quantum mechanics forbids it. A perfectly silent vacuum would require perfect certainty, perfect zero motion, perfect zero energy, and nature does not permit that kind of perfection. So emptiness has a background hum. Not sound, not matter, but restless quantum jitter, virtual excitations, a trembling floor beneath existence. This is not something you can picture easily. Your brain wants emptiness to be a void. Physics says emptiness is structured. And once emptiness has structure, temperature, is no longer impossible. Because temperature, remember, is not about matter. It is about energy distributed among degrees of freedom. The vacuum has degrees of freedom. Fields can carry energy. Radiation can pass through. Even nothing has a kind of motion, and there is another discomfort. Space is not isolated. The universe has a history. Even if a region is empty now, it was not always empty. Light has crossed it. Radiation has soaked through it. The vacuum is not a fresh canvas. It is stained with the afterglow of everything that has ever happened. So when you ask, how can space have heat? The deeper answer is, space was never truly nothing. Your intuition treats vacuum as absence. Physics treats vacuum as a state, a physical state with properties, with energy, with fluctuations, with temperature, and this is where the idea becomes dangerous, because if the emptiest place imaginable is still not empty, then the word nothing is not what you thought it was. It is not the absence of reality, it is a different kind of reality. You imagine space as dark, not just visually dark, conceptually dark. A place untouched by warmth. But the universe is not dark in the way you think, because even the emptiest space is not thermally silent. It glows not with visible light, not with starlight, with something older, something everywhere. There is a temperature that fills the cosmos, a faint heat that does not come from stars or planets or life. It comes from the beginning. This is the cosmic microwave background. A name that sounds technical, almost boring, but it should disturb you, because it means the universe remembers being hot. Right now, in every direction you look, space is filled with radiation, microwaves, a cold, uniform glow. About 2.7 Kelvin above absolute zero. That number is small, but it is not zero, and that is the point. This radiation is not localized. It is not coming from one object. It is not sitting in a cloud somewhere. It is everywhere. It is space itself carrying a leftover temperature, a fossil warmth, the afterimage of a universe that was once dense, bright, and burning. Before galaxies existed, before stars ignited, the entire cosmos was a hot plasma, matter and radiation tangled together. Then the universe expanded, and expansion does something your intuition does not expect. It cools. Not by losing energy to an outside environment. There is no outside. It cools because stretching space stretches light. Radiation loses energy as the universe grows. The glow fades. The temperature drops, but it never becomes nothing. So when you say space is cold, what you really mean is space is still cooling down from creation. Even in the deepest void between galaxies, you are sitting inside a bath of ancient photons, light that has been traveling for almost the entire age of the universe, not carrying images, carrying temperature. This is one of the strangest inversions of intuition. The emptiness is not empty. The darkness is not dark. The vacuum is not thermally blank. It is filled with the cooled remains of the early universe. And this is measurable. We have detected it. We have mapped it. The sky has a temperature, not metaphorically. Literally, if you could see microwaves with your eyes, space would not look black. It would look softly luminous. Everywhere, a uniform whisper of heat. So now, the question becomes sharper. If even the void is glowing, if even nothing carries the universe's leftover warmth, then cold is not the natural state of space. Cold is only what remains after an ancient fire, and that fire never fully went away. You imagine perfect cold as a destination, a final state. Remove all heat, remove all motion, reach absolute zero. It feels like a clean concept. a universe drained of energy. But absolute zero is not a place reality allows you to arrive at. Not in practice, not even in principle, in the way your intuition wants, because the universe has a floor, a background warmth that cannot be erased. Even if you travel to the emptiest cosmic void, even if you shield yourself from every star, even if you remove every atom, you are still inside the cosmic microwave background. Those ancient photons still exist. They still pass through you. They still exchange energy. Space itself has a minimum temperature set by the universe's history. So already, perfect cold is not available. But the problem is deeper. Even if the cosmic background faded away, quantum mechanics would still remain. A system cannot have perfectly zero energy, because perfect stillness would require perfect knowledge. And nature refuses perfect knowledge. There is always uncertainty, always residual motion. Even at the lowest energy state, particles jitter. Fields fluctuate, the vacuum hums, so absolute zero is not just hard. It is conceptually unstable. Your intuition treats temperature like something you can subtract away completely. Physics treats temperature like something tied to unavoidable structure, and that changes the meaning of cold. Cold is not emptiness. Cold is not nothing. Cold is a limit you approach but never reach, a horizon, not a point. The universe is not a machine that can be turned off. Even if matter vanished, even if radiation thinned, even if time stretched forever, there would still be some restless residue, some irreducible activity. So when you ask, how cold is space? The honest answer is strange. Space is cold, but not perfectly. Space is empty, but not truly. Space is quiet, but never silent. And the idea of absolute zero, the idea of total thermal death, is more like a mathematical ghost than a physical reality. This is another intuition collapsing. You thought emptiness meant the absence of energy, but emptiness has a baseline, a minimum texture, a leftover warmth, so the question shifts again, not why isn't space colder, but why does the universe refuse perfect nothingness? You keep wanting heat to belong to particles, to atoms colliding, to gas molecules bouncing like billiard balls. That picture is comforting because it ties temperature to something tangible, but the universe does not require tangibility. Heat is not married to matter. Heat is energy, and energy has more forms than your senses were built to recognize. By now, space having a temperature should feel less like a curiosity and more like a warning, because it means temperature is not a property of stuff. It is a property of physical reality itself. Radiation carries temperature. A bath of photons can be thermal. The cosmic microwave background is proof. No atoms are needed for that warmth to exist, just electromagnetic fields oscillating through the vacuum. So already, heat exists without matter, but even that is not the deepest layer, because radiation is still something you can imagine as particles of light. Photons flying through space, your intuition can hold onto that. Physics does not stop there. In modern understanding, particles themselves are excitations of fields. An electron is not a tiny marble. A photon is not a bead of light. They are disturbances in underlying fields that fill space everywhere. Which means the vacuum is not empty space plus occasional particles. The vacuum is the field in its lowest state. And the lowest state is not zero. It is not blank. It has energy. It has fluctuations. So when you talk about temperature of space, you are brushing against something unsettling. Temperature may belong not to matter, but to the fields that make matter possible. This is where language breaks down, because what does it mean for a field to be warm? It means the field carries energy distributed across its modes of vibration, not atoms vibrating, reality vibrating. Space itself is not a container, it is an active participant. And in some contexts, this becomes even stranger. Near a black hole, empty space does not behave as cold emptiness. Quantum field theory predicts radiation emerging from the horizon. Hawking radiation, a temperature assigned to spacetime geometry, not to matter, not to gas, to curvature, to gravity, which is almost impossible to fit into intuition. Heat without particles, temperature without substance, warmth emerging from the structure of spacetime itself. At that point, the original belief is completely destroyed. You cannot say temperature requires matter. Matter requires fields. Fields require space, and space is not inert. So the idea that the vacuum has a temperature is not an exception. It is the rule. Your brain wants a universe made of objects floating in nothing. Physics offers something colder and stranger. Objects are patterns. Heat is distribution, and emptiness is a state, not an absence. So when you look into deep space, you are not looking into nothing. You are looking into the lowest energy form of something unimaginably real. You began with a simple picture. Space is empty. Empty means nothing. Nothing means no heat. That picture cannot survive, because the universe does not contain emptiness the way you imagined. Even the void has a temperature. Even the vacuum has structure. Even nothing has properties. And once you accept that, the idea of reality changes shape. You are forced to confront a quiet reversal. Maybe the universe is not made of things inside space. Maybe space is not the stage. Maybe the stage is part of the play. The cosmic microwave background still glows. A faint warmth left over from the early universe, not attached to any object, not sitting somewhere, just everywhere, a reminder that space remembers, and quantum fluctuations persist, not because the vacuum is full of hidden particles, but because perfect stillness is not allowed. So, nothingness is not an absence. It is a lowest state, a physical condition, a kind of presence which is deeply unsettling, because human intuition treats nothing as the simplest concept possible. Nothing should be trivial. Nothing should be featureless. But physics makes nothing one of the most complex ideas we have. The emptiest regions of space are not blank. They are filled with fields, with leftover radiation, with the quiet thermal echo of creation. So what does it mean to say there is nothing there? It means only there is no matter there, but matter was never the whole story. You are living inside a universe where absence is not empty, where silence is not silent, where cold is never absolute, where even the vacuum cannot fully erase energy. And perhaps this is the deepest consequence. Reality is not built on objects. Reality is built on relationships, on distributions of energy, on patterns in fields, on a space-time that cannot be reduced to nothing. The temperature of space is not a strange detail. It is a crack in the world, because it tells you the universe has no true void, no perfect blankness, no clean separation between something and nothing. Even the concept of emptiness is physical, and that should leave you with a different kind of awe. Not the awe of distant galaxies, but the awe of the space between them. The fact that the universe refuses to give you pure nothingness, that even when you strip everything away, there is still a glow, still a fluctuation, still a measurable warmth. The vacuum is not a void. It is the quietest form of existence, and the universe, it seems, has never been empty at all.